This tutorial will walk through an example using binary outcome data. There are two sample datasets containing binary data in the mmeta package. They're called NAT2 and CA125. We will use the NAT2 dataset in this example, so let's go ahead and download the data and see what it looks like. As we can see, there are four columns, where y1 and y2 represent the binary outcomes for two measures, while n1 and n2 refer to their standard errors. For binary data, the methods that can be used to estimate the pooled effect and between-study heterogeneity are bb.cl, bn.cl, tb.cl, and tn.cl. These methods are valid under a working independence assumption, which sets the between-study correlation parameter to be 0. This assumption can be explained in more detail in the references that you can find at the end of this section. Now, the abbreviation BB stands for beta binomial, which is primarily used for data from case control studies and diagnostic accuracy studies. BN is an abbreviation for bivariate normal, and this is also used for case control data. TB stands for trivariate beta, and this is used for a mixture of case controls and cohort studies, while TN stands for trivariate normal, which is also used for a mixture of case controlled and cohort studies. The CL refers to the use of the composite likelihood method of estimation. And for more details on these methods, you can refer to the papers in the references section. Now we're going to take a look at this paper in particular. And if we look at equation 4 in this paper, we can see in the model that there are four parameters of interest. They are A1, A2, and B1 and B2. So now let's go back to our function in R, and we can type in the command. So here we just named it fit.bb, and following the structure of the command, we type mmeta, then the name of our data set, the type of data we're using, which is binary in this case, the number of outcomes, which is 2, and the estimation method for this example we'll use is bb.cl. Now we'll run this command. And if we ask for the summary of the output, we can see that the function estimates the log odds ratio for us, and it provides a confidence interval as well as standard errors for this value. It also produces a Hessian matrix in the log scale, as well as it provides the maximum likelihood estimators for the parameters A1, A2, and B1 and B2.